in order to answer this question, we do need to be able to write the equations for the reactions of barium hydroxide and potassium hydroxide, each with sulfuric acid, so that we know the ratio. So we've got two equations to deal with. So we've got acid plus alkali. It's going to make the salt. So the salt of sulfuric acid is a sulfate with potassium. Potassium's only in group 1 and a sulfate ion is 2-, so K2SO4, and water. And then we would need to balance that. And if we do that, we would get this as our ratio. If we swap to barium hydroxide having 2 hydroxide ions, sulfate ion being 2-, we're going to see that the ratio is going to be 1:1 with the barium hydroxide and the sulfuric acid. So we've got two different equations. In this one, we've got a 2:1 ratio, and in this one, we've got a 1:1 ratio. And we need to know which one would react with exactly 0.05 moles. So if it was potassium hydroxide, if this is 0.05, then this one would need to be twice that, 0.1. But if it's for the barium hydroxide, it would need to be 0.05. So we can calculate moles of each of these. Moles are volume times concentration. Moles are very clever, making sure your volume is in the correct unit. So turn it to decimeters cubed. So that's 0.05. Now for potassium hydroxide, we needed 0.1. Here we've got 100 times 10 to the minus 3 to get it into decimeters cubed times 2. So 100 times 10 to the minus 3 would be 0.1. And then times by 2 is 0.2. So neither of those two is the correct number. We needed 0.1 of potassium hydroxide. So this volume and concentration for C is actually the same as for B, so that would be 0.2. Again, we didn't need that, but we needed 0.05. This is the same volume and concentration as A, so it's going to be the same moles as A, and that is the one we needed, so we're going to select D as our answer to this question.